Assalamualaikum and hi to my dear lecturer and my fellow classmates. I am Aswad Shaharin from group number 9. In this video, I will present about our first group assignment, which the topic we have chosen is law motion, which is related to the application of first order differential equation. As you can see at the slide now, here is the contents that I will explain later, starting from introducing our group member until the conclusion of the assignment. So let's go to the first content. Here is the group 9 members. Starting from the left is our group leader Umairah Az-Zahara. Next is Muhammad Amirul Ashraf, Muhammad Takif, Nur Dayana Natasha and Mima Saf Aswad. Below the names is the tasks that have been divided and each of us play the roles productively for this assignment. Without further ado, let's move to introduction. Based on the topic law motion, the famous physician Sir Isaac Newton have introduced laws which still we have been using nowadays. Newton was a mathematician and physicist who experimented in a variety of fields. He developed gravitational theory when he was just 23 years old in 1666. He then published his 3 laws of motion in the year 1686. So what are the laws he published? The first one is Newton's first law. It stated that if an object is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. This law is often called as the law of the inertia. Next is Newton's second law. It stated that the acceleration of an object is directly proportional to the net force action on it, and is inversely proportional to the object's mass. This law can be written as F equals to ma, which is force equals to mass multiplied by acceleration. The third law is Newton's third law is it stated whenever one object exerts a force on the second object, the second exerts an equal force in the opposite direction on the first. As you can see, the equation have the same magnitude. The method used to solve the motion problem is by using differentiation and integration. Next is by using differential equation, and the way of solving the equation is using separable method. Next, we move on to the problem statement. As you can see figure 1 at the slide, there is an object with mass m attached with a parachute. The question is to determine how the equation of first order equation is formed by using differentiation and integration method, which can calculate the velocity of the falling object. The diagram is interpreted to the equation at the slide. There are constants used for this equation, and as you can see down there, it's written in when t equals to 0, v equals to 0. So now we already see the question. How can we solve it? Let's move to the methodology. Here is the overview of the methodology. You can see the equation used based on the problem statement. The unknown m, g and b are constant. First, we need to rearrange the equation. After that, we need to integrate both sides to get another equation. After solving the equation, we need to find the value of a by making v as the object. After we get the value of a, then we can substitute the constant value into the equation in terms of t. So let's see the manual calculation. On top we can see the first equation. On top we can see the first equation. The first step is to use separable method to get a new equation. Second step is to integrate both sides. After the integration, the equation is rearranged in order. Then apply exponent on both sides to eliminate the ln. Then we get the mg minus bv equals to a to the power of exponent negative bt over m. The equation is rearranged to make the v as a subject. This new equation is used to find the velocity at any rate of time. The third step is to use the hint at the question, which is t equals to 0 and v equals to 0, to find the constant a. Then we substitute the constant value of m, g and b into the new equation. After that, we have obtained general equation which is used to calculate velocity at any rate of time. Next, we move to results and discussion. At time 0, the initial velocity is 0 meter per second. The velocity reading is tabulated in the table 1.0 below every 5 seconds for a total period of 1 minute beginning at t equals to 5 seconds. As you can see at the slide, all the data collected for every addition of 5 seconds up to 60 seconds. Here is the graph plotted based on the table 1.0 reading. An accelerating motion is shown by the graph on the velocity versus time scale. Since a free-falling object experiences acceleration g equals to 9.8 meter per second downward, the velocity time graph is assumed to be like the graph shown. A closer examination of the velocity time graph shows that the object begins with zero velocity as shown by the graph and ends with a high negative velocity, indicating that the object is traveling in the wrong direction and speeding up. A negative acceleration is defined as a moving force that accelerates in the opposite direction. Since the object's acceleration is determined by the slope of any velocity and time graph, negative slope means a constant negative acceleration. The motion of a free-falling object with a steady acceleration of 9.8 meter per second in the downward direction is consistent with the study of the slope on the graph. That's all for the result and discussion, so we have reached the conclusion. As a final observation, we can see ordinary differential equations are formed by applying fundamental laws to specific problems in a broad range of practical contexts, such as theoretical physics and engineering. The object falls into vacuum in this case, and it is only exposed to one external force, which is gravity, which is represented as the object's weight. The gravitational force, represented as the weight of the object, is the only external force acting on an object falling to the vacuum. Free falling refers to an object that moves solely due to the force of gravity. There would be an extra drag force acting on the target if it were falling through the atmosphere. The first-order differential equation can be used for the resolution of this equation, especially a separable method, which is one of the best ways to derive and solve the problem. In conclusion, first-order differential equation can be used for the resolution of this question, especially a separable method, which is one of the best ways to derive and solve problems. And here are the list of the reference. So that's all for our group's presentation. Thank you for paying attention during this whole video. Hope this video can be a future reference for any problem solving question. That's all from us. Thank you.